G'day, my name is Chris Muflad and I'm a project engineer at Vico Software. Welcome to the Schedule Planner video training series level 4, 5 layers of LBMS logic. In this vignette we're going to teach you about the 5 layers of LBMS logic, why LBMS differs from CP/M logic, and we'll provide you with examples of each type. Location-based management systems involve several layers of interactive CP/M logic which combine to form a powerful location-based logic structure. Layered logic is not hierarchical, but is applied equally. One could argue that location-based logic is an extended CP/M logic. However, as you will learn, CP/M algorithms do not support continuity requirements needed to perform location-based planning. The first type of layered logic is external logic relationships between activities within locations. Let's check out an example of layer 1 logic. As you can see, we have a split screen view between the flow line and Gantt chart views. Here we have 2 tasks. Let's start by creating a simple finish to start logic link between each task. Keep in mind the Gantt chart view. The external logic of location-based tasks controls the links between activities or tasks within location, and this forms layer 1 logic. This greatly simplifies the complexity as it is only necessary to create a link between 2 tasks, which is then copied to each individual CP/M activity in each location. The second layer is external higher level logic, which is the relationships between activities driven by different levels of accuracy. Layer 2 logic extends layer 1 logic to provide CP/M logic where task relationships exist at different levels of accuracy. Each location-based task must be allocated to an accuracy level which corresponds to a hierarchy level in the LBS. Just as tasks have a location-based accuracy level, similar each link between tasks has an accuracy level. This link can be defined at any level of accuracy which is the same or higher, or less defined than the highest accuracy level of the 2 location-based tasks. In this example, task 26 must be completed in different locations before task 27 may start. Layer 3 is the internal logic. This is the logic relationships between activities within the same task. The third layer logic is critical to the achievement of flow of resources and uninterrupted work, and therefore may be considered flow logic. This is the internal logic within a task between locations, and therefore between the activities and locations that form a task. External CP/M logic may allow work to commence early. The work cannot proceed until the resources are released from the previous location. It is not that internal logic takes precedence, but rather that both apply. It's these internal logic relationships that allow us to force continuity. Let's start by first double-clicking on the task and selecting the paste function. Note that by pacing or forcing the continuity of this task, we have now achieved continuous flow through each location for this task. The fourth layer is phased hybrid logic, which exists between tasks in related locations. Layer 4 logic is required to model the special cases of location lags and sequencing of external logic. Just as there can be a time lag between activities in CP/M, there can be a location lag between tasks in location-based planning. We'll learn more about this in a vignette in this series. We use location lags to automate logic in related locations, for example by saying that work below needs to be completed before starting work above. Last but not least is layer 5 logic, which reintroduces standard CP/M logic links which can be between any task and within any location. Layer 5 reintroduces the CP/M logic, which is normally applied between tasks, but can be applied internally to a task as well. If applied internally to a task, the logic overrides the internal logic of that task. For instance, if you're trying to constrain possible sequences. If created between 2 tasks in 2 separate locations, like this example, follow the red lines if you will, this link type can be used to account for special circumstances, such as one part of the LBS affecting another part of the LBS. This layer is needed to model between different location systems, such as the difference between a structure and finishes phases of work. In this vignette, you've learned that layers 1, 2, 4, and 5 can be implemented using CPM forward-backward passes. You've learned that logic is replicated by locations as we create tasks using layer 2 logic, and that layer 3 internal logic relationships can be forced in location-based management systems to plan for continuity.